We had just finished in the previous video the Aufbau principle of just building up the atom one electron at a time, and we had finished the second row on the periodic table. So we had finished up through neon, and so that's where we finished. And so it's really important to notice where we are on the periodic table for each of these as we go through the process. Now let's just go on to atomic number 11. Now atomic number 11 is sodium. So we're going to want to fill in our electron configuration notation so that we get up to 11 electrons. Now we're going to skip the orbital notation now and just focus on the electron configuration notation. So 1s2 fills, and then we go to 2s2, and then we go to 2p, and it can hold up to 6 electrons. And then we go to 3s, and at this point we have 2, 4, 10, 12 electrons. And then after 3s2, we come to 3p6. That brought us up to the 18 electrons. And now we have, whoa, I can't add here. I'm going too far. That's way too many electrons. I only need 11. Backtrack. Bzz. Let's backtrack to 3s. Whoa, you're all saying he's getting carried away here. So 3s1, that gives us 11 electrons. Now remember, the electron dot structure only shows the electron in the highest energy level here, the energy level 3. So our electron dot structure is only going to have 1 electron. So we're going to have the symbol and this single electron that is in the sodium. Now if you remember, sodium with 1 electron is just below lithium, which had 1 electron, which is just below hydrogen, which had 1 valence electron. So we see this important trend in the periodic table, that everything in this first column has 1 valence electron, and we're going to see that this one ended in 1s1, and this ended in 2s1, and this ended in 3s1. So what is below sodium is probably going to end in 4s1. But let's keep on moving here. After sodium, what is magnesium with 12 electrons? And we're just going to write 1s2, 2s2, 2p6, 3s2. Is that 12 electrons? Let's add them up here. 1, 2, 3, 4, and 6 is 10, 11, 12. I got it right this time. And so our electron dot structure is going to have how many electrons? Well, the electron dot structure is only going to have the electrons from this highest energy level, so it's only going to have those 2 electrons, and they would be paired together in an orbital, and we would draw them like this. So let's move on to atomic number 13, which is aluminum. And we'll see that with aluminum, after we've filled 1s with 2, and 2s with 2, and 2p with 6, and 3s with 2. Remember, s can only hold 2 electrons, so we've filled up here. What comes after 3s? Well, after 3s is 3p. But we only need 1 more electron to get us to 13. So there are the 13 electrons for aluminum. But what are the valence electrons? What do we show in the outer shell? Well, it's the highest energy level, which is the third energy level. So we show all of these electrons. And two of them will be paired. That's the 3s2 electrons. And then 3p1 is going to be all by itself. That's the electron dot structure for aluminum. And if you look just above aluminum on the periodic table is going to be boron, and you'll see it also had 3 valence electrons. Moving on to silicon with 14 valence electrons, 1s2, so that's going to be let me count this up here, not a 3, that should be a 2, right? Come on, computer. There we go, 3p2. So the electron dot structure for silicon is going to have the 2 electrons that are paired in 3s, but remember the 3p electrons are going to go into separate orbitals before they pair. So that's your electron dot structure. Moving on from silicon to phosphorus, 1s2, 2s2, 2p6, 3s2, 3p. We're just going to add one more, so that'll be 3p3. And the electron dot structure will show the outer electrons. That would be these 2 and these 3. So the first 2 will be paired, but remember, these will go into separate orbitals before they pair. And we're going to jump ahead here. We're going to jump over the top of sulfur, which you would expect to be just like oxygen. Oxygen is just above sulfur. And we're going to skip over chlorine, and we're going to go right to argon. Now, argon, you would expect to see this. 18 electrons total. There are 2, and 2 more is 4, and 6 more is 10. And 2 more is 12, and 6 more is 18. So that's the electron configuration notation of argon. So what you will also notice here is that we have completed the third row on the periodic table. We're at the end of the third row. We're going to show the highest electron energy level, and there are the 8 valence electrons around argon. So you probably remember there's something special about this 8 electrons, and we call it the octet rule. And the octet rule is this. If you have the S and P sublevels of the highest energy level filled, that's 8 electrons, that octet makes this atom especially stable. It does not tend to react with other elements. And in fact, there is something especially stable about elements that can rearrange their electrons, either losing them or sharing them, to get this octet. That's one of the central tenets of learning how electrons interact to form chemical bonds. So we're at the end of the third energy level, and if we go on past argon to potassium at number 19, we're going to see 1s2, 2s2, 2p6, that's what fills next, 3s2, after 3s is 3p, That can hold 6. Now notice, before we finish filling the third energy level and going on to 3D, first we go to 4s1. That's the 19 electrons that we would find in potassium. So we don't actually fill the third energy level before we go to the fourth. So this means that potassium, with only one valence electron in its highest energy level, only has one dot. But we expected that because potassium is just like sodium, is just like lithium, is just like hydrogen when it comes to its electron dot structure. Now, as we move past potassium to atomic number 20 and go to calcium, calcium is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Did I get that right? Is that 22 electrons? 2, 4, 6 is 10 at this point. And then another 10 brings us to 20. That does look like calcium with 20 electrons. So our electron dot structure for calcium is going to include just these 2 electrons in the 4s energy level. So the electron dot structure is going to be calcium with 2 valence electrons. Now, as we move to atomic number 21, we're going to notice something interesting. We are going to start filling 3D because after 4s comes 3D, and 3D will have this one electron, but that's not in the highest energy level. That's in the third energy level. The highest energy level is 4s. So guess what the electron dot structure is of scandium? Well, there's scandium, and it's 2 valence electrons. So let's move now to atomic number 22 and take a quick look at that, and then we're going to be finished and go to a worksheet for a few minutes. So atomic number 22, titanium. Guess what the electron dot structure is? It is Ti, and there are the highest energy level electrons, so it also only has 2 valence electrons. And so what you will find out is that we never get more than 8 electrons in the electron dot structure of one of these atoms.